So first is the two insertion methods, which is insert v1 and insert v2. So first is the insert v1. So insert v1 uses a while loop for iterative insertion. So insert v1, as you can see in the code below, the insert v1 has implement a new item into the BST, which is the to create the new node, the BST node. So after creating the BST node, they traverse the tree to find the correct position for insertion based on the item values. So the new node is inserted either as the left or right child of the current node. Then next is the insert v2. So insert v2 checks if the tree is empty before inserting the item. So the same to the v1, both methods create a new node, which is the node, BST new node. They traverse the tree to find the correct position for insertion based on the item's value. So the new node is inserted either as the left child or the right child. Okay, next is the find smallest. So find smallest returns the smallest values in the BST. So the method checks if the current node this has a left child. That is the F method. So if there is no left child, it means that the current node is the smallest, and the method returns the item of the current node. So as the else statement says, if there is a left child, the smallest method is called recursively on the left child. That is the test left, the smallest. So the recursion continues until a left node is reached. The leftmost node and the smallest item is returned back through the recursive calls. So okay, next is the find largest or the public int largest. So largest returns the largest value in the BST. So the method checks if the current node this has right child. So if there is no right child, it means the current node is the largest, and the method returns the item of the current node. So if there is a right child, the largest method is called recursively on the right child. Otherwise, the recursion continues until a left node is reached the original rightmost node, and the largest item is returned back to the recursive calls. So next is the boolean contains, or the search method contains. So this checks if a given item exists in the BST. So as you can see, if int item is equals to int this item, so it means it compares the search item with the current node's item. So if they match, it returns true. Then if the search item is smaller, it searches the left subtree. Otherwise, if the item is larger, it searches the right subtree. So recursively repeats the process until a match is found or a leaf node is reached. So okay, next is the tricky part of the code. So I have the hard time on solving this problem, but I will explain this into a much simpler way of an explanation. So delete node. Delete nodes are node with a unspecified item from the BST while maintaining the BST property. So it is a deletion method. So the flow is it recursively searches for the node to be deleted. So once found, it handles three cases. So node if the node has no children, simply removes the node. Otherwise, the node has one child. It replaces the node with its child. Then, if the node has two child, it finds the in order successor. So this is where the part we use the in order to replace the node with it and deletes the successor. So okay, next is the pre-order, in order, post order, and level order. So these are the traversal methods. So these handles in traversing the tree in a specific order. So it performs dip first and breed first traversals of the BST. So for each node, it perform an operation. So for example, print the item. So it handles the traversal order of the numbers. So let's proceed to the other codes. First is the count nodes, count non-leaf nodes, count leaf nodes, and the height. So these are the statistic methods. So the purpose of these methods is to count the total number of nodes and the non-leaf nodes, the leaf nodes, and calculate the height of the BST. So these statistic methods, the count nodes, count non-leaf nodes, count leaf nodes, and height, is to recursively traverse the tree to count nodes, the non-leaf nodes, the leaf nodes, and calculate the height. So it means it returns the value of the count of the non-leaf and the leaf nodes, and returns the height of the BST. So next is the sum and is empty. So the purpose of sum is to calculate the summable nodes, and is empty is to check if the tree is empty. So sum recursively calculates the summable nodes in the tree, and the is empty, it checks if the root item is null. So another additional methods, which is to get number of nodes, to get number of non-leaf nodes, and to get number of leaf nodes. So this additional methods is the prefix to return a various statistic about the tree. So it returns the get number of the leaf nodes, and get number of the non-leaf nodes, and get number of the leaf nodes. That is the purpose. So next is the build method. So build method is to construct a sample BST. As you can see, the code provided, the this point def is equals to new BST item, and so on. It creates a sample of tree structure by assigning left and right children to the nodes. So this item here is the children of the node. So it is now constructed, as you can see. So lastly is the main method. As you can see, only half of the code is provided. So inside the main method, it accepts a user input to perform various operations on the BST, such as building the tree, searching, deleting, and displaying information. So this can be seen in the menu option. So to utilize the methods defined in the BST class based on the user's choice. So it depends on what to be inputted. So this is the running code. As I said earlier, it depends on the user's input. So this menu here has the build, the BST, search and item, delete, and the display BST. So after it is inputted, it will output the order of the precedence, the post order, the height, and the leaf nodes, count of the leaf nodes. Also, it outputs the smallest and the largest. So this is the whole running program of my code. That is all.